How's it going, everyone? It's Hobby from Worsters 1000. Today is January 27, 2021, and I hope you guys are having a good day. As today, we're going to focus on the potential major United States snowstorm that could bring over a foot of snow in the Midwest and Northeast going into next week. And we'll also talk about other snowstorms such as the upcoming Midwest and Mid-Atlantic snowstorm that could bring up to 8 inches in some areas, as well as the snow in the higher elevations of the Pacific West Coast. But before I begin, make sure to subscribe if you want to see more weather-related content. Make sure to like if you like this video, and make sure to turn on post notifications if you want to see even more weather-related content. So let's begin by first taking a look at the GFS model 120 hours out. And by the way, we're going to focus on the potential major Northeast and Midwest snowstorm that could happen next week going into Tuesday, where it could dump a large area of snow extending from Chicago, from Des Moines, New York City, Cleveland, Boston, pretty much all the East Coast cities, in fact, could get impacted by a major snowfall event. And I'd say at this point, it's looking even more impactful and will impact a much larger area than the snowstorm we just saw pass through the Midwest and the Northeast, which was already a relatively big scale snowstorm. And for me to say that this snowstorm is currently forecasted to be bigger than the most recent snowstorm we experienced in the Midwest and Northeast really says something about the magnitude of this potential storm and the potential of it to bring major impacts throughout a large population of the United States. But you see that. Let's begin by first taking a look at the GFS model, see what it is saying. And so the low pressure, the trough, will originate off the West Coast and will impact California at first with heavy rainfall right along the West Coast, as well as just very heavy snow in the higher elevations of California, where you could see over 4 feet in some areas in the higher elevations of California, as is going to extend all day in the higher elevations of California. And you also need to keep in mind the rain along the coast, because it could create some flooding concerns. And the good news is that you're going to see some rain in southwestern California, which has been in a little bit of a drought as of recently. So it's going to get much needed rain, but still watch out, because when it comes to flash flooding, it doesn't matter how dry it is. Flash flooding could occur at any moment whenever the rainfall rates are very high and heavy. So let's begin by first taking a look at the trough moving through the Rocky Mountain ranges, and you see there's a lot of snow extending all throughout the higher elevations out. I would say this is dumping at least a decent amount of snow. I would say maybe up to a foot in some of the extreme higher elevations, but for the most part, I would say the snow won't really affect the major cities, because the elevation at which it's gonna actually snow will be a little bit higher than the surface level of the cities to really bring a major snow event to Salt Lake City, Denver, or Phoenix. So I wouldn't worry about snow in those areas. However, the higher elevations definitely need to watch out for some snow. However, the storm really gets going and will really become the major snowstorm by the time it hits the Midwest, once it really encounters that unstable air, which is typically common for a lot of troughs once they reach the point of the Midwest, where you pretty much have a very, or at least an above average temperatured southeast right along the Gulf of Mexico, which is providing the southeast with a lot of warm air, a lot of latent heat, and a lot of water vapor as well for a lot of these troughs to work with once they hit the Midwest. And you're combining that with the fact that there's going to be a lot of winds from the lee side of these mountains, which are typically much colder than the warmer Gulf of Mexico water right around the warm Gulf of Mexico air from the Gulf of Mexico and along the southeast. And once the cool and dry air and the very warm, humid air of the Gulf of Mexico states combine, that really creates a very unstable environment once troughs hit the Midwest, and that'll really strengthen this storm significantly. But as it heads further and further to the east, and you see this drops down to 995 millibars after not even being visible, nearly not being visible in the GFS model, where you don't even see the low pressure system because it's so weak. But the GFS expects this rapidly strengthen by the time it reaches the Midwest, thanks to the increased amount of unstable air in the Midwest, and that's very important to keep in mind. And you see that not only will it grow stronger as the rain, the area of precipitation, such as rain and snow, will also grow much larger and will impact a lot more people as a result. And the storm overall, the area of precipitation is going to be a lot broader, which could lead to heavier snowfall accumulation amounts, like higher snowfall accumulation amounts, as well as higher rainfall accumulation amounts. Let me move forward to the latest run from the GFS, which just came out right now. So you see the storm rapidly intensifies by the time it hits the Midwest, and then it mainly maintains its strength, maybe weakens a little bit because the jet stream will straighten out a little bit by the time it hits the eastern half of the United States. However, it won't really prevent this storm from dumping a heavy amount of snow over a large area in the Midwest, where you see Minnesota, Chicago, Indianapolis, Cleveland, Ohio the snow is right at your doorstep, and we're seeing the heavy snow extend for a very large area, and it's going to be a long duration event just by the sheer fact of how large this storm is and how broad the area of precipitation and this snow swath is. So I would expect heavy snow all throughout the Midwest in this scenario, and a major snowfall threat if the GFS forecast scenario was correct. And then moving 102 hours from now, just after the 4-day mark, you see that snow is right at Philadelphia and New York City's doorstep, and it's already bringing heavy snow to Washington, D.C. and all throughout Pennsylvania, Pittsburgh. And this snow is still in the Midwest, keep in mind, where the Twin Cities and Chicago are still in the snow despite the low pressure already moving well to the east. So like I said, this is going to be a very long duration event, which is concerning because that will increase the snow. That could increase the snowfall total significantly. And you see the snow eventually heads into Philadelphia, New York City, the big cities in the Northeast, and we see that snow extend to upstate New York, and we see the storm strengthen quite a bit once it gets off the coast, where it's gonna have a lot of that warm Gulf Stream water it could work with and create a ton of convection from that warm Gulf Stream water, and also create rapid intensification off the coast, where we're going to see that cold air attempt to filter into that warmer Gulf Stream water vapor filled air, and that'll force a lot of that water vapor filled air, that humidity, upwards into the atmosphere, and as a result, we're going to see a lot more condensation, and that'll create more precipitation, higher rates of precipitation, and stronger updrafts, which will create higher rates of precipitation, where that thunderstorm activity off the coast will eventually change over to snow once it encounters a cold air. And there's going to be plenty of that based off of what the GFS model is saying. Keep in mind that there's still a little bit more than 5 days out, so there's still a lot of time for the GFS model to iron out its forecast, but it's not looking good, especially when you consider the fact by how slow this storm moves once it reaches the Atlantic Ocean, where by the time it gets off the coast of the Northeast, you're going to see that this storm barely moves at all, and pretty much over the same 24 hours, the low pressure is going to pretty much stay within the same vicinity and area for just a very long time, where it doesn't move very rapidly or much at all, as it just meanders just off the coast of the Northeast, which is the worst case scenario, since that'll bring just a ton of snowfall in this scenario, where the snow will dump a heavy amount of snow for a long period of time. It's not like we're the Midwest, where yes, the Midwest will still experience potentially major snowstorm in this scenario because of how broad this snow swath is, and how heavy at times the snow is. However, it isn't. However, the Midwest. However, when the storm's in the Midwest, it's gonna move at least a decent pace. By the time it gets off the coast of the Northeast, it's just gonna stay over the same area for 24 hours, and that's a major concern because that'll bring the snow totals way up along the East Coast, right around the I-95 corridor. So to give you guys a better idea of what I'm talking about, let's compare the next 24 hours of this storm in the Midwest compared to the 24 hours in the Northeast. So let's start at the 84-hour mark. And 24 hours from 84 is 108 hours. So within that 24-hour period, the storm moved from Missouri all the way to Ohio. So it moved at, I would say, a decent clip. Compare that to the once this storm is off the East Coast. Let's start from 120 hours from now. The low pressure is approximately right around Maryland. 24 hours from now, it's barely moved at all from Maryland, just off the coast of New Jersey. So it hasn't moved much at all, and it's moving at a very slow clip by the time it gets off the coast of the Northeast. And you might be asking, what is the reason why it's going to move so slowly by the time it's off the Northeast coast? Well, we have to zoom out a little bit to the North Atlantic map to give you guys a better idea. And we also need to change the current map we're looking at from the radar map to the 500 millibar MSLP height. And you see that going into 120 hours from now, the low pressure is right around this area. And then I noticed by the time this storm reaches the Northeast coast, the low pressure is going to jump a lot in different places because there's going to be areas of increased instability off the coast of the Northeast. And because since it's going to be over very warm water, there's going to be increased convection in this area, which will mean that this low pressure will weaken to a point where it'll be weaker than the convection that's happening off the coast of the Northeast. So this low pressure will essentially jump off the coast. However, it's still going to stay over the same areas. And the reason why is because there's going to be a big blocking ridge in this region where, if you take a look, there's a little bit of a dip in the jet stream right here. However, there's a little bit of a bump in the jet stream right here where there's a strong ridge bringing a lot of warmer air to northward right around eastern Canada. And it's going to sort of create a negative tilt where the jet stream winds will face a little bit northward, maybe a little bit northwestward at one point to keep the storm meandering over the same area. It's not typical for the jet stream to have winds that directly go from south to north yet, and even northwest, because the Coriolis effect always diverts the winds towards the east and pretty much steers the jet stream winds towards the east along with the westerly winds. However, in this case, it seems like there's going to be a big enough jet stream dip to force a lot of ridging around eastern Canada and steer this and make the storm get trapped a little bit by this ridge right here and this ridge that's expected to form right around eastern Canada. So it's going to move very slowly as a result of this block in the middle of the Atlantic and extending to eastern Canada, and it's pretty much going to just stay over the same area for a long time off the East Coast, and that'll be the worst case scenario. The European model isn't as lenient in doing that. I noticed that the European is more lenient on taking this a little bit more offshore to not bring a major long duration snow event, as major of a long duration snow event along the East Coast. However, I noticed that the European is also agreeing that there's at least going to be some sort of block in the middle of the Atlantic that's going to force the storm to move very slowly. Let's compare the European over the next 24 hours. We see the low pressure is right around the Midwest at this point, right around the Ohio River Valley, and I noticed that it's a little bit weaker than the GFS and a little bit slower than the GFS. However, it's still strong enough to bring a decent amount of snow throughout the Midwest and a decent amount of snow right around Virginia and the Mid-Atlantic states. And if we move 144 hours from now, it doesn't move very fast either, where the snow is still where the snow is still over Virginia and the Mid-Atlantic states, and it's going to stay over that area for quite a long time, where even 24 hours beyond 144 hours from now, it's still just hugging the coast of North Carolina and Virginia, which is just insane to see during the winter, where typically the jet stream winds are just very strong and wouldn't allow something like this trough to move this slow in the northern hemisphere during the winter right around Canada. And it's quite rare to see this, to be honest, where this storm is moving this slow, and that's a major worry when it comes to snowfall because of this. However, the timing of when the European and the GFS does this is still varies. However, they're both agreeing that this storm is going to just move very slowly off the East Coast, which could make it a much more dire situation when it comes to the snowfall forecast for the East Coast. However, I want to show you guys the current snowfall accumulation from both the European and the GFS model, because I find it interesting, because while they're both taking a major snowstorm and very similar paths once they reach the Midwest, they kind of divert where they're going to bring the heaviest snowfall by the time they reach the East Coast of the United States. Let's take a look at the current snowfall accumulation forecast for the GFS, and you see that if we move around the same time period as the European model, you see that the GFS model is more lenient on bringing the heaviest snow further up north, while the European is persisting on bringing the heavier snow further south to where Virginia and North Carolina are affected more, and Northeast, I would say, like New England and New Jersey, Pennsylvania, the tri-state area, is getting impacted less by snow, where they aren't experiencing much snow at all. Maybe 3 to 6 inches in New England, but that's about it. While the European is receiving far more snow, and it's a major snowfall threat for you guys, as the European is more lenient on bringing this low pressure system further south. And you might be asking, why is that? Let's take a look at the 500 millibar height and MSLP. Let's take a look at why this is, and let's zoom out to show you guys exactly the differences in trajectory in these storms. And I think the reason why is because the GFS has a little bit of a stronger ridge just off the coast of the southeast, and this stronger ridge will divert the jet stream winds from mainly going from west to east direction to more of a southerly to northerly direction, which would steer the slow pressure system a little bit further north than what the European model is saying. Because I've noticed with the European model, it's not bringing as strong of a ridge just off the coast of the southeast, which is limiting the steering flow that would steer it towards the north. And while the European does steer it north eventually, I noticed it does it far too late, to the point where it's well offshore by the time it makes that turn up northward, as it doesn't expect the ridge to build up very quickly, and it expects it to build it up very slowly. So I don't think that the European is steering it all the way more northward because of the weakness in the ridging. Let me zoom out to show you guys, because it's easy to see how the European isn't taking much of a ridge at all. So let's compare the European model's case to the GFS in 120 hours from now, and you see that there's a little bit more ridging, to the point where the GFS lists this ridge as being strong enough to steer the storm up northward, while the European model doesn't really have much of a bump, while the GFS model has a little bit more of a bump in the jet stream to allow this storm to move a little bit further northward, I noticed. And also depends on this ridge as well. If it's a little more northward, then it's less likely to bring then it's more likely to move northward, this low pressure system. However, if it's further southward, then it's less likely to do that. And you clearly see the European 120 hours from now is taking this ridge a little bit further southward, which is blocking the storm from really going up more northward, while the GFS is taking this ridge a little bit more northward, allowing for more snow right along the northeast and impacting Virginia and North Carolina less than what the European model is saying. So there's still a lot of time. We need to see how these ridges build up and how the timing goes, because timing will also be key with this. And pretty much we just need to see how this jet stream forms over the next several days, because that'll be important in determining what type of snowstorm you'll see and how much impact you'll see in your current location. And it's very important to keep that in mind. So as of right now, however, if we were to take let's say the GFS model was correct in terms of its snowfall forecast, the GFS would take over a foot of snow right around Pennsylvania, New Jersey, New York, and over 8 inches all throughout the Midwest. And the European is also agreeing with this, where it's taking quite a bit of snow throughout the Midwest and the Ohio River Valley and the Mid-Atlantic states. So at this point, it seems like both the European and GFS model are leaning to the fact that there's at least going to be a major snowstorm with this. There's going to be a major snowstorm out of this trough moving through the eastern half of the United States. But the big question remains, where exactly? There's higher confidence that the Midwest will receive a major snowstorm. However, where exactly in the Northeast will experience the most snowfall, we have to wait and see, as there's still a lot of time for the forecast models to iron out the forecast. And you see that while the GFS is taking more snow along the Northeast, the European is more southerly with the heaviest snow. So we just have to wait and see. There's still a lot of uncertainty. If I were to show you guys my snowfall forecast map, I put the most likely scenario of where the most major snowfall will be possible is right around the Mid-Atlantic. This includes Washington, D.C., Philadelphia, New York City, and a lot upstate New York, Pennsylvania, and heavier snow throughout the Midwest, and moderate snow just south of that. However, this could easily change over the next several days. I want to emphasize that while I think it's more likely than not we see a major snowstorm somewhere in the United States, exactly where remains the question. And just stay tuned and very closely if you're in the Northeast and the Midwest, because I think this could be major and potentially historic if everything goes right, because the storm is just going to move very slowly, indicated by both the European and GFS model. Once it's off the coast of the United States, once it's off the east coast of the United States. So during situations like this where it's going to move very slowly and it's going to be relatively powerful, that's something to definitely watch. So I'd just stay tuned very closely if you're in the Midwest and the Northeast. However, outside of this snowstorm, we also need to keep track of this upcoming snowstorm that could dump a decent amount of snow throughout North Carolina and Virginia and the Mid-Atlantic states, where there's going to be a trough moving through, and this could dump up to 8 inches in some areas. Let me show you guys the current projected snowfall forecast from the GFS model. You see that there's a good area of 1 to 3, mainly through the Ohio River Valley just south of it, extending to Missouri. However, you see that once it reaches North Carolina and Virginia, you see an area of 5 to 8 inches. So I'd expect a major snowstorm for those close in proximity to this, like Roanoke and right around Asheville. You could experience some snow, and even as far east as coastal North Carolina, where you typically don't see much snow, could experience a decent amount of snow from this 3 to 6 inches right around the coast of North Carolina, and even West Virginia could experience maybe an inch of snow. So this could be major. Watch out headed into Thursday, because it's expected to be the worst at this point. And in terms of the timing of this, very early on Wednesday, this should be the worst for a lot of you guys in North Carolina and Virginia. And for a lot of the Midwest and Ohio River Valley, it should be the worst right around Wednesday afternoon. So definitely keep that in mind. But anyways, guys, I thank you guys for watching. Make sure to subscribe if you want to see more weather-related content. Make sure to like if you like this video, and make sure to turn on post notifications if you want to see even more weather-related content. And I hope you guys have a good day.